Let us discuss the phenomena of Doppler's effect in light. For light, we can always state in case of light, always velocity of observer or velocity of source are always taken very less than the speed of light c. So we can keep Doppler's effect symmetric with respect to source or observer. That means you either consider the motion of source or that of observer. It will be resulting identical things as speed of light is very high. So many students might confuse with that. Let's prove the analysis also. Say in a situation if there is a source which is moving with a speed Vs towards a given observer, and say the light is also traveling at a speed c, and the source is having frequency n0 with which frequency of which the light is emitted from the source, and observer is just looking into the light. So we can say the frequency of light which is detected by the observer, this apparent frequency can be written as n0 multiplied by c minus Vs, as per the relation which we have obtained in the previous cases of Doppler's effect in sound. The only difference is here c will represent the speed of light. In the previous case it was the speed of sound. Now in this situation, say if we consider source to be at rest, here observer we have taken at rest. Now if I take source to be at rest, which is emitting frequency n0, and at some distance observer is moving towards the source with the same speed, say Vs. Now in this situation we can say the apparent frequency in this situation will be n0. This will be c plus Vs by c. Now here we can rearrange this expression as an apparent is equals to, we can write it as n0. This can be written as 1 by c upon c plus Vs. I have taken the numerator into the denominator, and in this situation I can write it n apparent is equals to n0. This can be rewritten as 1 by 1 plus Vs by c to power minus 1. I've just rearranged the terms in the denominator, and as Vs is very less compared to c, here I can apply the binomial approximation and take this negative sign in. So this n apparent can be written as n0 into c by c minus Vs. You can see this expression is exactly same as that of this. That means whether observer is moving with the speed Vs or source is moving with the speed Vs, as the two are approaching, you can directly use the common result. So in general cases of Doppler's effect in light, for ease in calculation, we generally consider observer to be always at rest. So you can write down this note: for Doppler's effect in light, generally we take observer to be at rest always, as it won't make any difference on the result. Even if the velocity of observer is accounted in the relative speed of source with respect to observer, the result will remain same, because the speed of observer and source, which are very less compared to speed of light, it is symmetric with respect to either of these we can take. So be careful about Doppler's effect in light. It can be directly used by just taking the relative velocity of source with respect to observer. In sequence we can state as observer is taken to be at rest. This implies due to motion of source, apparent wavelength of light changes. The relative change you should always keep in mind, like if there is a source and there is an observer, and say if source is moving towards observer with a speed vs, in this situation the wavelength of light which is traveling at a speed of c towards observer, its wavelength after emission from source is taken as lambda apparent, which is always considered as less than the actual wavelength if lambda naught is the actual wavelength, because source is moving towards the observer. Similarly, if situation is like this, which we already studied in the section of Doppler's effect in light, one source is moving with a speed vs away from observer. In this situation, the wavelength which is emitted and which is approaching observer will be lambda apparent, and it will be more than the actual wavelength, because source is receding away, so wavelength will be expanded. So you must be careful about that. In next section, we'll also calculate the shift in wavelength or the wavelength which is emitted from the source due to its motion either towards observer or away from observer.